In this video, we are going to find the sum of the series of 2 to the n plus 1 over 3 to the n times minus 1 to the n. So usually for these kinds of problems, you're given a series and you're asked to determine whether it converges or diverges. And if it converges, you have to say to what and which test you use to figure that out. So for this problem, since it's asking us to find the sum, I guess we technically already know that it's going to converge, but let's review how we would figure that out. So if I have a series from n equals 0 to infinity, where I have a times r to the n, we need to check something about r to figure out whether it converges or diverges. So if the absolute value of r is less than 1, then the series converges. Now, if the absolute value of r is greater than or equal to 1, then the series diverges. Now, if the series converges, then we know that this series equals a over 1 minus r. So we want to find the sum of this given series. So first, let's try to write it in the form of something times something to the n. So I have 2 to the n plus 1 over 3 to the n times minus 1 to the n, so it's already kind of close. Now I'm going to factor out a 2, so now I have 2 times 2 to the n over 3 to the n times minus 1 to the n. And now I see that I have 3 things raised to the nth power, so I can collect them all together and write this as the sum from n equals 0 to infinity of 2 times 2 over 3 times minus 1, so I'll just put the minus sign here, and this is all raised to the n power. So now what I have here is 2 is a, and minus 2/3 is r. So now let's check. The absolute value of r is equal to the absolute value of minus 2/3, which is just 2/3, and that is less than 1. So yes, this series converges as we expected. Now what does it converge to? It converges to a over 1 minus r. So that is a over 1 minus r. So I can rewrite this as 2 over 1 plus 2/3. So I can rewrite this as 2 over 5/3, which this is the same as 2 times 3/5. So this is 6/5 is the final answer. So this series converges to 6/5. If this video was helpful, please like and subscribe. And if there are any problems you'd like to see worked out, feel free to email them to ashmath1729@gmail.com.